Okay.
Ready?
Yeah.
Okay. Okay. The first thing I'll do, you're going to go to the Gen5 icon. You're going to double click on that. That's your software that runs the microplate reader. This is a Gen5 BioTek. This is a BioTek microplate reader. It's run by the Gen5 software. You want to go to create a new item. You want to create a new experiment. And so go up here to your default protocol and say OK. Now this gives you your blank slate to work with. So now you got to go through each one of these things, well these two, and pop them open. And you're going to have to complete certain things in each little set in order to make the plate read and read what you want it to read. The first thing you need to do is double click on procedure, and that's going to tell the machine how far on the wavelength you want, what the steps should be. Anybody got a pen? Awesome. So what this is doing, like this goal, this is a wavelength, the wavelength of light on the x-axis. So it's going to shoot a wavelength of light at every wavelength. So if you wanted to do every 2 nanometers, it's going to shoot the light through, and it's going to get a point on the spectrum that tells you, okay, how much light is absorbed. If it's a lot of light at that wavelength, you're going to get a higher little value here. So one, you can do it at every wavelength, or you can do it at every 2 or every 4 or every 10 or whatever. But eventually, you're going to get a plot of the amount of absorbance at every wavelength, and that's what we call an absorbance spectrum. So basically, that's going to tell you what color, because that corresponds to the wavelength of light. That's going to tell you what color your particles are. And because of gold nanoparticles, this peak down here around 520 nanometers or so, depending on how wide that peak is, it's going to tell you how monodispersed or how widely varied your particle sizes are. And it's also going to tell you how concentrated. So the more concentrated your solution of gold particles is, the higher the absorbance value is going to be at that wavelength. So you're going to see a peak down here on this end that is consistent with gold chloride, which was the starting material, because all of it probably didn't convert to the gold nanoparticles. So what we're trying to see is our peak centered around 500 nanometers, and to see for various samples that you have in the plate how they compare with each other, because we're going to take them and stack them up on top of each other in an Excel chart to see how they relate to each other. Okay, so that's that. So told you all that so I could tell you how to determine how you're going to do your protocol. So now after you clicked on procedure, you're going to go into read. So double click on that. So you want to do an absorbance spectrum, which is just saying measure the absorbance at every wavelength. You're not going to do endpoint, because if you're doing endpoint, you would have chosen 5 or 6 specific wavelengths that you want to measure the spectrum at, and it was just going to measure the absorbance and give you one number for each one. We don't want that. We want a spectrum. We want to do the whole wavelength range. We want it to start around 300 nanometers and stop around 700, which is fine. It'll give us enough range to see what we're looking for. And since we're trying to find out the delicate differences between each batch of particles, we're going to do all the way down to 1 nanometer. That's called 1 nanometer resolution. So we're measuring the wavelength of every single nanometer. Okay, so what I should have done, I didn't do. So you can go back in here after you've picked. I need to go over here and tell the computer program where my samples are. If you don't have a full plate, then you don't want to leave it like this, because it'll read the whole plate and it'll take forever, because it reads well by well, one well at a time. So you uncheck, use all the wells, and then you select a range of wells where your samples are. Where are your samples? And
A1 through 6, B1 through 6.
okay, so we're going to go A1 through 6, B1 through 6. Now, every sample you run, you have to take a blank. So you're going to have to use an empty cell to measure the absorbance of the plate, so it can be subtracted out of the absorbance that you read. So we're going to measure Since it's A1 through 6, we can't leave out. We can't just do this one and this one, leave that one out. We're just going to go A1 through 7 and B1 through 7 and say okay and okay. And now we can say okay again. And so now you want to go up here to plate layout and tell the program which sample is which, where your stuff is, where your blank is. So we could actually go in and name our samples, but it's not really necessary if you make a note of your plate in your notebook as to what's where. So the type of sample, the type of item that's in the well, first thing we're going to do is sample. Sample 1, 2, it just automatically numbers them up. And then we come down here, sample, 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 sample. Now we have to identify a blank. We're going to tell it that that's the well we want to subtract as the blank. So go up and select blank. ID's blank. We only need 1 because you confuse the program. There's a way to do it with 2 where you average them and subtract. Let's just do 1. Keep it simple. That's our blank. That's what the plate looks like. When we actually collect the spectra, we'll have a layout that shows you the spectrum in this one, this one, this one, this one, etc., etc. Now we're going to say okay. So now we need to go to data reduction. What data reduction is, it tells us how we're going to process this sample after we take the spectrum. So the only thing we really are concerned with doing is subtracting the blank from it. So what you want to do is go to transformation, double click, and basically it's pretty much already set up. You want to verify that it is subtracting the blank, which is what it's doing. So it says X minus blank, sample X minus the blank in all of the wells. So that's good. So that's okay. Okay, and now we're ready to run our spectrum. What you want to do now is come up here and click on the read plate and say read. And you're going to give it a name. Probably need to make yourself a folder. But for right now, we'll put it on the desktop. Today is the 9/19. You need to get yourself a file naming convention for these files. Go Spectra, Nicole, and
My name's Roshi.
that's why I'm like, wait a minute. I'm like somebody's mama. What's your name, child? All right, save. I don't think I put it on the desktop. I put it in the experiment folder. So now it's going to say put your plate on there. And you could have already done this. But what you want to do is you want to sit it in here. Could have put it in there. It could have already been loaded. But there's a spring load. So you just kind of want to feel for. Make sure it's in there. Don't jerk it or handle it, damage it. Handle it lightly. Make sure it's snugly in the spring load. Close the top and then press OK, and the spectrum will start to read. When you get ready to look at your results, you can kind of look at them as you go, but you can't look at the final spectrum with the blank subtracted. So if you go up here, you can see, okay, this tells me where the samples are. This one will give you a curve, and you see this blank now because we haven't really finished measuring any curves, but it'll give you kind of a look into what all the curves look like. If you go curves, blank spectrum, that'll show you what it looks like with the blank subtracted. If you go just regular spectrum, that's going to give you a series of numbers, and you can tell it, okay, show me the absorbance at, 9 nanometers, whatever nanometers are specified over here to show you what the absorbance is there. And that's good for when you want to compare several samples to see what the absorbance is at each sample at one specific wavelength if you want to compare. So you could just have them all displayed at one wavelength, etc., etc. But what I like to leave it on is curves blank spectrum, and when it finishes all of them, it's going to come back and pop up. After you do that, you're going to want to export. Let me show you how to do the data export. This is what your curves look like. You can double click on one and you can see this is what a curve may look like. This is what we expect the curve to look like with gold. So let me show you what one looks like with gold. We can close that experiment. Just like any window, this is your experiment right here. No, this is your experiment right here. So we're going to open another one. So this is a whole bunch of samples. Curve spectrum. So this is what your goal should look like, something like this. This is a really good sample. This is just a spectrum. Now we see blank spectrum. We see that's been subtracted. So yeah, that's it better. That's a pretty good sample. So we can see that this is what the absorbance is. We see that we look at the width of this and say, okay, it's not too bad, it's not too broad, so that's a good particle. Now what we want to do is take this and go to where it says view data. That gives you all of the numbers, wavelength versus absorbance of that cell, of that one plate wheel. So now you can go, we need to toggle between view chart, view data, view chart, view data. But when you're in view data, you want to go ahead and press the Excel button. And what it's going to do is it's going to open up your data in an Excel spreadsheet. And every time you press it, it's going to add your data to the same sheet underneath that set. So as long as you know which sample is in B1, B2, B3, B4, etc., you can plot it. So you come over here and you select all your data that's going to be on the y-axis, which is going to be your absorbance values. And there's sexy ways to get around having to do all this scrolling. We took it from 200 to 900, I think, on his. I don't know why Excel stopped scrolling. Okay. So now you go to, oh my head. Oh, where's my chart function?
Insert.
Where do you see?
Second one. Go back. Yeah.
All right. You want to do a scatter plot with your thingamajiggers, with your points. And of course you want to go to select data, and then you want to dadgummit. I'm going to do a scatter plot. I didn't finish it first. And that's that. So now you want to click on the chart, and now you want to do select data, and you want to edit your series to where you include all of these X values. So what I do is I copy this, Control C, look at the Y values, and you know these are in column A. Or you could go over there and select them by pressing this first and then going over here and selecting all of these. And now you call it B1 or whatever your sample name is. And that's okay. And so now, okay. And the thing that we probably will do is to do a scatter. Go ahead and change the data type, chart type. Nicole, change chart type to a scatter without the points. We want the smooth line, and that'll help pretty it up a little bit. So now before we do that, we can go back over here to our experiment. We see this data, we can just X off of this. Now we can go back and get the next one, another one that we want to compare it with. Let's say A4. Go view data, export to Excel. Whatever Excel file is open, it's going to put it in there. You see it blinking down there. And so now what we want to do is add this series to this one. Sometime when they put it at the bottom, I take them and I copy them and I make them all to where they're side by side because we're using the same set of X values. So now what we want to do is just go and add a series here. We're going to go back to our chart, and the easiest thing for us to do is to move this chart. Oh, move chart. We're going to move this chart to make it a chart by itself. You can name it something that identifies what the chart is, but for right now I'm just going to move it to where and get it out of the way. So now, where's my... Where's my sheets? Anybody see my sheets? Group 1. Oh, okay. There we go. Alright, so now we at this chart, we're going to go to select data. Now we want to add a series. We want to go and select our Y values. So we're up, we got it out of the way. Now we're going to go to sheet 1. And you're going to come down here till you find wherever that data set started. And we're going to go and select all of those. Now when you're comparing them all, that they've been taken at the same wavelength interval, then you're okay. Because now you can use the same ones that you used before if you want to. You can use those, or you can go back up here and use these, either one. Because they're the same wavelengths that we're comparing them against. Now if you're comparing two spectra that have been measured at 2 different resolutions, one was measured every 2 nanometers, you can compare them, but you can't use the same spectrum. You have to use its own spectrum. So we're going to call this one something else. I think it was A4. So now you got both of your charts in the same, both of your spectra in the same chart. It helps you to be able to compare their concentration, their color, their wavelength, their purity, and it helps you to be able to make a decision as to which one is which. And the way to format your Excel charts to where it looks good in a presentation is to come in and do a right click on here. And you're going to do format chart area. You're going to have no fill. You're going to have a solid black line of a border. And you want to make it, you know, a nice black or something like that. You want to make it to where it's, you know, probably about a point. No dash, okay, and that's cool. Now you want to come in here and format this area, plot area. You want no fill, border color, solid line, same thing. I thought this was a plot area I was doing a few minutes ago. So it's probably better to not have a border around the whole thing. So we're going to take this border off. Format chart area.
At the bottom.
Thank you.
Second one. No, third one.
Third one. We'll just say
No,
no
two
line.
line.
Okay. And so this probably needs to be thickened up a little bit. So what I want you to do, where styles, thicken this up to about 2, maybe 2.5. Because what we want to do is make it really big and nice, so when you shrink it down and put it in your thesis or your paper, it's readable, it's you know, nice and already formatted properly, and they're going to be consistent. Other thing you need to do is make this a shoot. There's another way to do that, where it's a wide one. Play with that.
It should be in landscape.
It should be wide.
Yeah. You can bring it out on the side.
It's another way to keep from having to do that, but for right now I'm going to do that. So what we want to do now is make sure our axes are formatted nice to where they're going to look right when we get ready to put them in the thing. So you're going to do your, I forgot, shoot. Yeah, chart layouts. No, source data, layout, chart title. We don't put a title on here because that's going to be in your figure caption in your whatchamacallit. Your axis title, you want a primary, you want it below the axis, your title, and then you want to put your y-axis vertical, and yeah, no. This one, which one is it?
That's not it. You got to go back to axis title.
Okay, thanks. vertical axis. Yeah. So this size needs to be, I usually like to do it in 24. So the same way you do your formatting, make it about, it's going to look really ridiculous for right now. But that'll make sure that when you shrink it down, it looks really nice. And then these numbers, we need to format the y-axis to where we tell it, let's see, we don't want to have to see this because it's not important. We're only interested in a region that's about 1.5, and absorbance is in arbitrary units. So our maximum is going to be about 1.5. Our maximum is going to be minimum is going to be 0. In the place where our horizontal axis crosses, it's going to be at the, if we don't have a 0 and 0, it's going to be at the minimum axis value normally, but it's okay. So this we don't want. All we're interested in is from here to here. So we do the same thing for the x-axis. Format the axis. We go from about, I'll say, 300 to about 800. We can even go to 850 or 9. We can go to 900. And depending upon, you know, what your styling is going to be, if it's too much, too many increments in here, you can adjust that here too. You can tell it to reduce the number of, you know, increments that your numbers are in by doing this in your major unit, etc., etc. So for right now, we're good. So that's cool. We want to get these horizontal lines off. Format plot area again. Where is it? Field. I just told you no field.
That's gonna do your board.
We'll figure that out at some point. That's the grid styling, I guess. It's chart type. Okay. Maybe a place up here to do our grids, our lines, plot area, grid lines. We don't want any grid lines on this chart. So now that's your template. You know, you can make yourself a template. So now you can save one file to where every time you compare a set of goals, whatchamacallit, all you got to do is take that data and come paste it on top of this area so it'll automatically populate, put in your chart. You can do the same thing by, you can copy this chart and paste it to where you can take some of these spectra out, put new ones in, so you can get a different view to compare by, etc., etc., etc. So the way I like to compare the goals is to, my head hurts, is to drop a vertical line here and just get an idea of, make sure it's straight, just to get an idea of whether or not they're the same wavelength or not. And in this case, this one is shifted a little bit, so they are different colors. This one is that way a little bit, and that's what we're going to be measuring when we try to see if the sensors work. We're going to be measuring whether or not
The peak shift.
the peak shift.
Mm-hmm.
So now we want to know by how much we can go in here and we can put our cursor on where we think the actual maximum peak value is. You put it on that line right there, it's just going to be in the way on the line. But you can come in here with your cursor and you say, okay, that maximum peak value is at about 516, 517. The other way to do that is to say, okay, is it about 516, 517? Let me go to my chart and find out for real where is it. Let me go to my data. So you look for the highest value between, you know, around that area, 516, 517. So we see that, yeah, the highest value here looks to be about 520. Mm-hmm. So it might not necessarily look. So sometimes you have to stretch it out even further.
Mm-hmm.
But that's that, and you can stack them up. You can have all your things to compare. Blah blah blah. Is it done? Now let's look at yours right quick, and then I'm fixing to have to get on the road to take my class. So these are yours. So this is what you're gonna get. That's one of your spectra. Blank spectra, curves, yeah, blank spectra. You can view your data. You can do the same thing with it. I'm not gonna do it right now, but you can always come back and do it. But
Can you export to a Excel file and save to our flash drive?
you have to do them individually. There is a bulk export. I gotta remember how to do that. I can't remember how
You
to
want
do
to do right there, not less?
it.
You can leave it like that. We can do it.
There's a power export here. One of these exports all of them at one time.
We can do it.
I'm just looking at them. I'm kind of curious to know what they look like. What?
So I can turn this off.
Mm-hmm.